Strange new worlds to discover. Understanding the universe's origins. In search of life in the universe. These are the mission objectives of the James Webb Space Telescope, the long-awaited successor to the Hubble Space Telescope. Join us as we investigate NASA's James Webb Telescope terrifying discovery. But before that, we welcome you all to our YouTube channel. We post daily updates from the world of space. Make sure to subscribe to our channel to never miss out on any of our latest videos. NASA launched the Webb from French Guiana on Christmas Eve in collaboration with the European Space Agency and the Canadian Space Agency. The telescope is now on its way to a location nearly 1 million miles away from Earth. On its journey, the telescope must perform demanding mechanical moves. Because the telescope's so huge, it had to be launched folded up inside a rocket. It must unfold its different components, from its sunshield to its mirrors, over the course of several weeks. According to NASA, the mission might be doomed by more than 300 potential technical issues or single-point failures. But when it fully deploys in space, the Webb will usher in a new age of astronomy, scientists say, and show humanity things it's never seen before. The Webb represents the culmination of decades, if not centuries, of astronomy, says Sarah Seeger, a planetary scientist and astrophysicist at MIT. We've been waiting for this a very long time. Scientists started thinking about a follow-up even before the Hubble Space Telescope launched in 1990. After more than 3 decades in space, it's unclear how much longer this boundary-breaking satellite will be able to scan and photograph the universe. The Webb was originally supposed to launch in 2010 and cost around $1 billion. Its price tag ballooned to $10 billion, and it's way overdue. But the wait will be worth it, at least according to scientists who expect new and revealing glimpses of our universe. We're going right up to the edge of the observable universe with Webb, says Caitlin Casey, an assistant professor of astronomy at the University of Texas at Austin. And yeah, we're excited to see what's there. The Webb will surpass the Hubble in several ways. It will allow astronomers to look not only farther out in space, but also further back in time. It will search for the first stars and galaxies of the universe. It will allow scientists to make careful studies of numerous exoplanets, planets that orbit stars other than our sun, and even embark on a search for signs of life there. The Webb is a machine for answering unanswered questions about the universe, for exploring what has been unexplorable until now. Here's a guide to what the Webb is capable of. The launch of the Hubble Space Telescope, named after famous astronomer Edwin Hubble, was itself a huge leap forward for astronomy. Here on Earth, astronomers seek out remote mountaintops and deserts to build major telescopes for the best chance of viewing a dark sky from pollution and bright lights. But their view is still marred by the slight haze and luminescence of Earth's atmosphere. Space is the ultimate mountaintop, as NASA explains. There's no better view of space than the one from, well, space. Hubble has meant so much during its 30-year run. For one thing, it sent us unforgettable, jaw-droppingly beautiful images like those of the Lagoon Nebula and the Pillars of Creation. It's also taught us about the age of the universe, about what happens when stars explode, about black holes. It helped establish many of the boundaries that Webb hopes to push. Most powerfully, its observations have led scientists to believe that the universe is expanding at an accelerating rate, propelled by something so mysterious that scientists simply call it dark energy. The Webb is, controversially, named for the man who led NASA in the decade leading up to the moon landing. James Webb, its namesake, was a government bureaucrat at the time when it was federal policy to fire gay staffers. While current NASA Administrator Bill Nelson said that the agency has found no evidence at this time that warrants changing the name of the James Webb Space Telescope, more than 1,700 people have signed a petition accusing Webb of complicity in discriminatory policy. Namesake aside, the technological achievement of NASA's newest telescope is uncontroversial. It's set to take the success of the Hubble a step further. What we're going to get is a telescope that's about 100 times more powerful than Hubble, says Amber Strawn, an astrophysicist at NASA who works on the Webb. How? The Webb improves on Hubble in 2 key ways. The first is just its size. Hubble was about the size of a school bus, whereas Webb is more like the size of a tennis court. The thing is enormous, Strawn said. Webb is by far the biggest telescope NASA's ever attempted to send into space. But it's not the total size of the contraption that matters. When it comes to reflecting telescopes, the key component is the size of its curved mirror. You can sort of think of a telescope mirror like a light bucket, Strawn says. The more light you can collect in this bucket, the fainter and farther away things you can see in the universe. Hubble's mirror was an impressive 7.8 feet in diameter. Webb's beautiful gold-hued mirrors combined for a diameter of 21.3 feet. Overall, that amounts to more than 6 times the light collecting area. What does that mean in practice? Well, consider one of Hubble's most famous images, the deep field. In 1995, scientists set Hubble to stare off into a teeny tiny patch of sky about the size of the head of a pinhead, held at arm's length from the viewer, and captured as much light as it could from that one spot. The image that came back was astounding. Hubble uncovered thousands of galaxies in this teeny patch of sky, helping us refine the number of galaxies thought to exist in the universe. The Webb's other advantage is the type of light it collects. Light comes in a lot of different varieties. The human eye can only see a narrow band known as visible light, but the universe contains lots and lots of light outside this range, including the higher frequency, higher energy forms, ultraviolet gamma rays. Then, there's the lower energy light with longer wavelengths, infrared, microwaves, radio. Infrared light is often very old light due to a phenomenon called redshifting. When a light source is moving away from a viewer, it gets stretched out, morphing into a longer and longer wavelength, growing redder. The opposite is true as well. As light sources grow closer, the wavelength shortens, growing bluer. It's similar to what happens when a siren goes by. The pitch increases as the siren approaches, then decreases as it trails away. Because space is constantly expanding, the farthest things away from us in the universe are moving away from us. Scientists are clearly raring to go, but the Webb revolution has taken a while. One reason for all the launch delays had to do with contractor Snaffus. But a big source of them all, NASA's Strawn says, is the complexity of Webb itself. Because it's so big, there aren't any rockets that are big enough to launch it fully developed, Strawn says. That's why the telescope had to be folded up to fit inside a rocket. So the whole process of building a deployable telescope in space is the source of a lot of the engineering challenges. Upping the stakes is the fact that while the Hubble was launched to around 340 miles above the Earth, Webb will be almost 1,000,000 miles away, 4 times the distance from Earth to the Moon. It means Webb will be unserviceable by human hands if it breaks. That's scary considering the history of the Hubble. Shortly after the Hubble launched in 1990, engineers realized there was a problem with its mirror. The telescope's initial images came back fuzzy, and astronauts had to launch a space shuttle to fix it. That won't be possible with the Webb. It just has to work. Let us know your thoughts on this. We're more than happy to hear from you. With this, we reach the end of today's video. Thank you all so much for watching, and I hope to see you again.